Hi everyone, thanks for coming. So I'm Alfie, there's me in front of a waterfall. I've been at ARM for a couple of years and spent far too much of that time on functional multi-versioning, which I'm going to talk about now. So we're going to go quickly. What is functional multi-versioning? So the problem is that when you're distributing a project, if you distribute source code, then you make your lawyers sad, and you make your clients sad because then they have to compile it themselves, and they don't like that. And so we end up saying to anyone who wants to distribute code, please compile your code for the major targets: AH64 Linux, AH64 Darwin, AH64 MingGW, AH32, and the other targets that I'm reliably informed exist. And then you've got to produce those binaries, and then ARM comes along and says, we've made a bunch of very fancy hardware extensions. We've paid compiler engineers a lot of money to spend time making sure code gen works. So please redistribute your code for this one, and 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 this one. And then the project author releases code for the ARM v8 baseline and makes us sad. And leaves a lot of performance on the table and hardware architectures unused. And there are lots of solutions, or attempted solutions at this. Functional multi-versioning is only one of them. What it is a way to recompile a function in your project multiple times for different targets, and then at load time, the correct version is selected. So this is very little runtime cost, a bit of binary size cost, and some load time cost, but who cares? So this is what it looks like. So you can annotate a function saying, please make this function twice, once for the sort of baseline and once for SIMD. Or you can use target version and say, here is two different versions I've beautifully made. And if this sounds a lot like ifunc, that's because it's essentially syntactic sugar on top of ifunc. Right. What's the history of functional multi-versioning? Because it's not a feature that ARM made up, we can't claim any credit for it. I think it was, I looked through the log, it looks like it was originally a feature of the Intel compiler. It was added to x86 a long time ago, and has sort of slowly been added to other targets with some sort of interest recently. It's definitely not our idea. Now time for code slides. So there are two big annotations with functional multi-versioning. Oh, not two big ones, there's only two. The first one is target clones. There's a bit of sort of subtle difference between the two. So target clones reproduces the exact same function. So this one function gets compiled multiple times, with the same C body producing different functions. So you can see here you've got the default version, which is sort of compiled against ARM v8 without SIMD, in this case, because it makes my slides better. And then you've got the version with SIMD, where you can see the code was beautifully vectorized. And then it emits a resolver, which is the code that gets executed at load time to choose which version should be loaded into the foo symbol. And then if you look at the very bottom, you can see that it calls out to that resolve symbol. So that's target clones. Target version is fairly similar, except that you have to write multiple versions of the same function. So the idea behind target version is more, this is also what x86 calls target, but we can't call target for complicated reasons. So you write multiple versions of code, and in any version for a specific hardware extension, you can make use of intrinsics and whatnot for that target. So here you can sort of do some beautifully hand-optimized code that the compiler helpfully converts into the exact same code as the auto-vectorized version. But it's just two ways of sort of achieving the same thing, one of which you can spend more time and more precision. Okay, so that's what functional multi-versioning is, but what have we actually done and can claim credit for? So the first thing is we added support into AH64 using target version instead of target attribute. There's a big request from some of our clients we speak to support functional multi-versioning across translation units. Specifically, they wanted to be able to have the main logic of their project untouched, and the alternative versions for different extensions in a different file. And this required quite a different sort of semantic model to what the x86 model is. And the current x86 model that's there seems sort of to have some intricacies that are either bizarre or buggy, depending on how you look at it. And I would love to know from someone at x86 what their intended behavior is. So that's something we worked on. So because we're using this target version attribute instead of target, we've decided that's enough to sort of diverge semantically. So one of the things we support is functional multiversion translation units. Another thing we wanted is, previously you could only define a function set with just target versions or just one target clone. We wanted to be able to sort of start with a target clone, but later down the line split out one version to a target version or whatever, so we've allowed that. And I've got a patch set adding support for target version in C that hasn't been approved yet, but hopefully soon. Hopefully for GCC 16. And so we've made the behavior more consistent, and we had a broken static inlining optimization previously. I made it, I turned it off for a while, and then I made one that works. And so that's what I've done. And we specified it. I tried my best to find some specifications for how the x86 version is supposed to work. There weren't any. I was gonna say, I don't believe there are any for any target, but now there's some for ARM. Yes, there's some articles, but no sort of formal description of behavior. Yeah, but anyway.
I would agree, but I'm saying it's not a specification.
Yeah, but so that's something. And and again, so we've sort of hopefully made a semantic model, because we've specified it and spent a lot of time arguing about it, hopefully made sort of a cleaner semantic model overall for how functional multiversioning should work. And we've sort of aligned that between our LVM team and our GCC team. So hopefully they should be fairly compatible. But no one's used it yet, so I'm sure we'll get bug reports. So let's have a quick look. We don't have a ton of time, but let's have a quick look at what each one looks like of those things we've added. So functional multiversioning, this is sort of the imagined use case, here's my beautiful project where I've got this function foo, and then I need a header file where I describe that function, and I need to describe those other versions there as well, because we need to know to mangle foo and to create the dispatcher. So that's sort of a caveat, but then you can stick your other versions in a different file far, far away. And that all works fine. Great. So again, target version and target clones interoperability. So here you can see there's sort of, you can do this both ways. You can either have the default version with, with some extensions and then one separate one. Or you could have sort of the default version defined as something, and then sort of, here we've got SVE and SVE2 pulled off. So you can imagine you were trying to make versions for both of those using SVE intrinsics, which obviously SVE2 supports as well. So that's what that looks like. Okay, and then I briefly wanted to talk about some of the weirdness we fixed, because I really want to know if this is a bug so that I can fix it, because it's kind of a nightmare. So x86 with target semantics does something quite bizarre where it will mangle target clones as you would expect. So you've got a default version, the other version, the resolver, and then your dispatch symbol takes the name of what the function was, right? So if you try and call into that function, you're just calling the dispatch symbol, right? But if you define something with two target attributes, the default version keeps the function name, and then you get the you get the resolver mangled as you would think, you get the AVX2 version mangled as you would think, and then the dispatch symbol gets some other name. And all the calls within that translation unit get redirected to call this .ifunc name. But if you're calling it from a different translation unit, you just call the default version directly. This seems very bizarre and not desired, but so if anyone is familiar with x86 FMV and knows if this was intentional or if this is a bug.
Are they trying to bypass the default version when you're calling within a TU? I remember that being a significant win from the Intel group.
What do you mean, sorry?
So instead of, when you have a versioned function, instead of going all the way back to your resolver, you want to go directly to the
Yeah.
target version based on where they were. So if you were in a target version for AVX 512, if you do a call to another version symbol, you want to go directly to the AVX 512 version as opposed to back.
So that's the static inlining that's the static inlining optimization I talked about. They had a broken inlining optimization that I removed and made one that works.
That's the only thing I could think of.
But this isn't that. This is only if you're in a different translation, because there's a difficulty if you're calling from a different translation unit that you can't really do any optimizations. But it's weird to call directly into.
Go, Richie.
Richie.
No, I would say it's simply not being used that way. Either it's not used at all,
Yeah.
or it's always used like to initialize some function table pointer.
Yeah.
And you always do the indirect dispatch.
Yeah.
Apparently nobody noticed. It looks broken.
Yeah. But the fun thing was that it used to be that it got mangled twice, the indirect to name, which is very creative. I like that. That's a fun way of mangling something. But anyway, I fixed that.
It sounds like a bug.
Yeah, it sounds like a bug, but it was something like there's a patch that changes the behavior to this without any explanation why. So I don't know.
Who's the patch from?
I don't remember.
Okay.
I'll have a look. Anyway, let's. Enough of me complaining. What would we still like to do? So we need to. Our ACLE specifications that we wrote are still in beta because we're expecting people to tell us they're wrong. If no one tells us they're wrong, they will exit beta. It will come as a surprise to some people, but ARM intends to make more hardware extensions. And when that happens, we intend to update function multi-versioning with that. We also, similarly to RISC-V, want to add priority syntax to sort of overrule the default ordering. There's an algorithm for generating the ordering of what should be chosen over what if you have all the extensions turned on. And that's sometimes not ideal, so we'd like users to be able to do that. Which, if there's anyone in RISC-V who's involved in that, I would like to talk to you because it's kind of, it seems like there's some more complexity there that isn't being dealt with that I'd like to know how you deal with it. And then, yeah, we would like some real-world use, really. Specifically, it would also be nice if some parts of the GNU toolchain were using this, just so then we would know if we broke it. But other part, obviously we would like people out in the world start using it as well.
You got to get it released first.
Got to get in the release. It's in 16 now, so.
And probably the way to think about it is 16, even though you are quote-unquote exiting beta, until you get that real-world use, expect bugs.
Yeah. Yeah, well, now we get the bug reports, which will be fun. So I'm sure my life will be nice and quiet. Okay, and then what do we want to do in my hopes and dreams? So one thing I'd like to do is unify these semantics across targets. I had to add loads and loads of quite ugly, if these targets do this, otherwise do this, that I would love to remove. So if there's anyone who's sort of from other backends who wants to talk about that, I would love to talk about that. Obviously, it would be nice to be able to support targets that don't have ifunc and sort of make this sort of a wider thing, but that's very ambitious. Yang Chen made a very interesting patch for being able to sort of specify a JSON file where it says, for these functions, please add these target versions. So you'd be able to do this versioning with no source code update at all. That's really cool, but sort of probably needs more discussion. We would love to sort of add some more potential extensions. So sort of saying, if you're on this, recompile this once for this core to say, if you're on that core specifically, please go and do this tuning for that core, and you can get sort of speed ups for that. Possible things like that may be interesting, but again, sort of depends on interest and feasibility, really. And lastly, we'd really love, especially if we're going to start doing this guided by sort of profile optimization, it'd be really nice to claw back some of that binary space that we've spent if we haven't improved. If we recompile this for a different extension and we work out that none of that extension is actually used, just to delete that version and just not bother. That would be a lovely thing to be able to do, but it's probably quite difficult.
I wonder, at least with factorization,
Yep.
you could do ICF at the very end before it.
How do you mean,
I
sorry?
don't know if the extension got used until well after ICM is done.
Oh, no, I said, that's why I said redo it.
Oh, okay.
I didn't say,
Okay.
do it at the current position. I said redo it towards the end.
Okay, I missed that.
Yeah, it would be.
After factorization for the top.
I think it would be difficult because I think you've already created the resolver at that point. So, and you've already sort of determined the ordering. And so sort of my main idea would be to, in that case, just alias that version to a different version. But you can't always safely do that. Okay, is that what that is? Okay.
Yeah.
But even then you can't safely always do that because you can't always determine if this version wasn't taken, what's the next version that should be taken or whatever. Like it's quite complicated how we would do that. But yeah.
And is it that important? Question.
Yeah, no, that's a really good question, and I'd love to know. I'd love to know how much people care. Like, if we, increased binary size by 50%, how much would people get upset at us?
Yeah.
It's
And
hard to
I don't
know.
have to worry about binary size anymore.
Yeah,
I'm in a different space than I used to be in.
yeah.
Same here.
So yes.
I mean, we do a lot of work more on the multi-heading side.
Yeah.
And I'm just wondering whether it's a different aspect of the same issue. And I wonder if there's a mechanism to tie the two together. Say, if I've got this string of I'm thinking RISC-V.
Yeah.
And if you look at something like NIOS 5, it's got 21,000 possible multi-head combinations.
Yeah.
Actually tying those two mechanisms in. So almost you could say do FMV for this function to match the multi-libs that are enabled in my compiler.
Oh yeah. That would be.
That might sort of simplify.
Yeah.
You can just see your annotation on your function is going to take 27 pages on this file.
And how many multi-libs do you have? Like, because I'm curious.
I say NIOS 5 potentially has 21,000. And the problem
Okay. I think multiplying binary size by 21,000 might be less popular.
So but you start. I think there are problems that for RISC-V. It's not your problem. It's a RISC-V problem of addressing scalability.
Yeah.
And how do you work out which of those you actually need?
Yeah, and that's
or
something.
how do you dynamically load them in?
Yeah.
So yes, you've got them all sitting on a server somewhere, but you only pull in the ones that you want.
Right.
I think the RISC-V problem is a bigger problem.
Oh yeah, all RISC-V problems are big.
Yeah.
What we're doing is not scalable.
Yes.
Yeah. But as I say, I think we do have some similar problems. Of, like there is a combinatorial explosion, and it's only going to get worse. So we need to do some work. I'm probably tight for time now. But
No, one time ago there was a mechanism that the LD.SO would look at the AT-HW cap and decide and look at a specific path to load an SO file from there.
Yeah.
Does that still exist? Is that
Yes.
helpful for this problem or?
It should be at least a subset of this class of problems.
yeah,
Be for multi-lib more, I would think.
I did absolutely nothing in the linker, so I have no idea.
Yeah, I mean, it's not nearly as fine-grained.
There's no priority.
No, there's no priority.
Yeah.
There's it's useful, but it plays in a different space than what he's trying to solve.
In terms of real-world use in the toolchain, have you talked to glibc at all?
Not particularly. I mean, I've got glibc people in my team, but I think there would definitely need to be more community openness to supporting this. I know they make heavy use of ifunct, but I don't. Yeah.
Not just iFunks, I think they can make heavy use of FMV in general as well.
Okay. Well, that would be
There are parts
fantastic.
of glibc that can benefit from being able to use certain extensions.
Yeah.
And produce some variants. So I think that would be a really good place to start having some discussions.
Yeah. I mean, I wasn't even certain if glibc would be okay with like more load time stuff and where that's acceptable and where that's
Well,
not.
I mean, they already do it.
Yeah, that's fair enough. Yeah, sorry.
Have you done any work with regards to debug information and how to make different versions addressable in debugger?
No, but it should be fine. You can just sort of address them by their symbol names, I think.
Yeah, so, but the problem is that if you have multiple targets and you use a symbol name, GDB at least will always list all the possible options, and there will be no way for you to filter out which one you want.
Oh, I see what you mean.
Their specific addresses.
I did some work to make sure the function names internally in GCC are sensible, because they weren't previously.
The main names or the
Both. Like the internal names. I don't know if that's what gets used in the dwarf info. I'd actually have to look. That's a good point, though. I should check.
I think GDB doesn't just, when you give it a symbolic name, it's going to put a breakpoint on every variant of that symbolic
Yes.
name, right?
Yeah, it will put, for breakpoints it will be fine. I'm thinking about listing. And
Yeah. No, I should look into what that does.
I don't know what GDB does for that. It's been a long time.
I've been specifically working on that for multiple linked namespaces, which is why I'm thinking about this.
Yeah.
You'll get like every single version leaked.
Yeah.
Really know ways
That's
to
probably
filter
not
out.
what you want.
Yeah, probably not.
Okay, that's a really good point. I should look into that because I don't know what it does. And it would be nice to make it do something sensible and probably reasonably easy. Great, I'm well over time, so I'm gonna cede my space. Thank you everyone for listening.
Questions are good.
Yes. Right, I don't know who is next. Yeah.